So we want to begin with this chapter. This chapter talks about functions, exponential functions, and things of that nature. What happens with exponential functions? You could easily solve question number one. Question number one said if f of x equal to x squared minus 3x minus 1 and g of x is this, what's the value of f of g of minus 2? So you see, all you need to do is g of minus 2. See, once f of g, so you could easily put this 1 minus x, as x here, and then drop minus 2 as that. Let's try that. We have 1 minus x all square minus 3 into 1 minus x minus 1. That's f of g. Okay, f of g of minus 2. So let's do that. 1 minus x all square give you, that's 1 minus x, 1 minus x. Looks hard to do, but it's well worth it at the end. So you have 1 minus x, that's minus 2x, minus x times x plus x squared. And we have, expand this, minus 3 plus x plus 3x. Minus 3 plus 3x. Then you have minus 1 at the end. Now that is your f of g. This is f of g. F of g of minus 2, that's what we're gonna do. Minus 2, we're gonna put minus 2 in. And when we put minus 2 here, we'll be having minus 2 here. Minus 2 times 2 will give you 4. Minus 2 times 2 will give you 4. That's 1 minus 4. I think we should move this to our open board. Let's move this to our board. Let's take this to our board. So we have 1 minus 4. 1 minus 2 times minus 2. That will give you 4 plus 4. 1 plus 4 plus, put minus 2 here. Minus 2 squared is 4. Then minus 3 plus 3 times minus 2 is minus 6. So minus 6 here. Then minus 1, and that's it. Oh, let's do that from left to right. 1 plus 4 will give you 5. 5 plus 4 will give you 9. 9 minus 3 will give you 6. 6 minus 6 will give you 0. 0 minus 1 will give you minus 1. Any other thing you do in this particular thing will give you a wrong answer entirely. So let's move on. Alright, so we have question number 2. If f equal to minus 4, 12, minus 2, 4, 2, 0, 3, 3/2, these are all coordinates, and g are this. What is the value of g of f of 2? Okay, so if these are all coordinates, you need to ask yourself, what does this represent? Now, this is not a time to go and start drawing a quadratic equation, no, or is it a time to start drawing maybe if the graph of this function or things like that. This is not a time to do that because that will take lots of time, because I'm just looking for g or f of 2. All you need to do here, all you need to know is look at this question very well. Look at this question very well. If you see f of 2, what's f of 2? F of 2 is, f of x. F of x. Okay, f of x is actually equal to y. So what is f of x? F of 2 is 2 here. F of 2 is 2 here. So what's that? F of 2. F of 2 is actually end up be making 0. So f of 2 is equal to 0. Look at it very well. Now, so if f of 2 is equal to 0, now put that in g of whatever f of 2 is. That's g of 0. So go and put g of 0 here. G of 0, you end up having 1. Look at the 1 just beside it here. Alright. Now let's use something, the same idea, and try solving the first one that we just did. If you have g of minus 2, put in 1 minus minus 2, 1 minus minus 2, what would you get? You get 1 plus 2, that's 3. Okay, then drop it into this. You have 3 square minus 3 times 3 and minus 1. 3 square is 9, minus 3 times 3 is 9, minus 1. We still got the same answer that we did that time, minus 1. Okay, so you could be fast with it when you get to this. So you can use any of the method to solve it and you'll be correct. Let's go to question number 3. A function f satisfy f of minus 1 equal to 8 and f of 1 equal to minus 2. A function g satisfy g of 2 equal to 5 and g of minus 1 equal to 1. What is the value of f g minus 1? Now this is almost similar to that f that tiny this and g, that f of tiny g. It's also similar, but how? The only thing is that you have to first do whatever g of minus 1 is. So they said g of minus 1 is 1, so g of minus 1 is 1. So you have f of 1. And what is f of 1? F of 1 is minus 2. So that's the answer. That's the answer. F of 1 minus 2. So if you look at this one, if f of x equal to 1 minus 5x over 2 and g of x equal to 2 minus x, what's the value of f of g of 3? I know you could easily do this one. All you need to do, replace it in. Replace g of 3 here. This is 3 minus 2 minus 3, and whatever answer you do, replace it in here, and that'll be your answer. Try it. If you don't get D, then you're wrong. Then let's go to question 5 and 6, and it's referring to the following information. The table above gives values of f and g at selected values of x. So if you have f of g of minus 2, I want you to find the value of f of g of minus 2. So this is your x of minus 2. So g of minus 2, you see, g of minus 2 is actually 0. So you have of f of 0, and go to 0. You see, f of 0, because that 0 now is now the x 0. You have f of x as 6. Watch what I did again. They said g of minus 2. I'll go to minus 2 because minus 2 represents x. Okay, f of x, g of x. So I'll go to minus 2. What is g of x of minus 2? Is 0. So I drop 0. F of 0, because that's what it is. After doing what's inside, it's f of whatever come out of what you did inside is 0. So I have f of 0 there. And f of 0, you go look at the f of 0. This is 0. where a0 is x, the f of that 0 is 6. So our answer is 6. Let's go to the next one. G of f of 3. You can easily do that. If you solve that and your answer is not 4, then you did a wrong thing. Alright, let's move on to the next section. Okay, so when it comes to recursive formula for a sequence, describe how to find the end term from the terms before it. Okay, a recursive formula consists of two parts: an initial condition that shows where the sequence starts, a recursion equation that shows how to find each term from the terms before it. We'll be looking at that while solving. Alright, the sequence is recursively defined by this: an equal to square root an minus 1 square plus 2. If a is 0 is equal to square root of 2, what is the value of a2? So what does that mean? Now the first thing you're going to look at, so when we are looking at recursive formula, we're looking at how we could make it, we could do something over and over, although in SAT not many times, okay, but doing things over and over. Let's solve this particular one: an square root an minus 1 all square plus 2. If a0 is equal to root 2, what is the value of a2? Now let us do this. An, let's look at a1 first. You know, an, where n is 1, we'll just simply put it, because we want n1 minus 1 to give us 0, because they told us what a0 is. So we'll start from a1, because a0 is root 2. We already know what a0 is, so let's go and do that. So we have an minus 1, which is root 2, and in fact this thing is root 2 squared from here, because a0 here, or should we write it out? Let me write it out so that you understand it better. So we have square root of a0 all square. We have a0 all square plus 2, and I'm sure you could do this. So a1 is equal to, what's that a0 again? Root 2. So let's go. a0, which is root 2 square. Be careful not to go and think that it's covering the other square. The other square still remains, so you have plus 2. So a1, let's do it. This is 2 square, 2 square. This is just 2. 2 plus 2 will give you 4. Square root of 4 is 2. So a1 is equal to 2. Okay, look at it. Root 2 square. Root 2 square will cancel out, so we have the square and the square root will cancel out, so we have 2 plus 2, which is 4. Square root of 4 equal to 2. So once you have gotten that, let's put it again in this same equation, in this same one here. Now the a2 will now be, you see, an minus 1, that's 2 minus 1, that's a1. So we are going to be putting a1 inside. A1 is actually 2, so we have 2 square. Okay, we have 2 square plus 2. So since we have 2 square plus 2, that's a2. a2 is equal to 2 square is 4, 4 plus 2 is 6, root 6. Okay, so that's the answer. Alright, let's move on to the next one. A sequence is recursively defined by an plus 1. All these are SAT2, you know, and you are writing SAT2 from what we're talking about then. So let's look at this. A sequence is recursively defined by an plus 1 equal to an fan over gan if a0 equal to 1, f of x equal to x squared minus 3x, and g of x equal to 2x minus 3. What is the value of a2? Okay, so from here we have a0 is equal to 1. We're going to put we're going to put that here, a0. So we're going to be looking at since a0 is equal to 1, we're trying to look at if you put 0 plus 1, that's a1 here. So if you say a0 there, if you're trying to put a0, so 0 plus 1 will give you that's a1. Okay, a1 is in fact that's a2, because if I do a1 to give me a2, but let's start with a1. So what we're looking at here, if I have an plus 1 and I want to use a0 as n, 0 as n, then this place will be a1. That's what I was trying to say. Then this an here will be a0, which we know, minus f of a0. So we're going to put f of a0, where a0 is equal to 1 as f of 1, f of 1 and g of 1. So f of 1, what will f of 1 be? This 1 square minus 3 1 times 1. So that's 1 minus 3. 1 minus 3 is minus 2. So we have minus 2 over d of a, and just put the 1 here. 2 times 1, 2. 2 minus 3 is minus 1. So we have minus 2 over minus 1. And a0 here is 1. What is minus 2? What is minus 2 over minus 1? Minus 2 over minus 1 will give us minus 2 over minus 1 will give us plus 2. So we have plus 2 here. The minus is still affecting it, so 1 minus plus 2, and that will give us 1 minus 2. 1 minus 2 is minus 1. Be careful about all this negative blah blah blah, because they could cause problems. So we have minus 1 as a1. a1 is minus 1. Now let's insert that minus 1 as a1 into this. So we are looking at a2 now, because this a2 equal to a1. See what we're doing? Recursive, like this, you're repeating the same thing. This is not a big deal. When you say recursive, you're just trying to do the thing again and again. So f of a f of a1 now, a1 f of a1, that's minus 1. We put minus 1 into the equation, into f of x here. So it's minus 1 square is 1. 1 minus, this is minus 3 minus 1 is plus 3. So we have 1 plus 3 there. 1 plus 3. 1 plus 3 is 4. So we have 4 over, then put the minus 1 here too. 2 times minus 1 will give you minus 2. Minus 2 minus 3 is minus what? Minus 5. Minus 2 minus 3 is minus 5. So we have a1. a1 was minus 1 here. Minus 1 minus this minus can affect this other minus, so it's plus 4 over 5. That's minus 1 plus 4 over 5. But wait a minute, what is minus 1 plus 4 over 5? How can we get minus 1 plus 4 over 5? The best way to do that is to twist this. Switch this around. We have 5 times minus 1, that's minus 5. Minus 5 plus 4 all over 5. And what's that? Minus 5 plus 4 is minus 1 over 5. And we have seen the answer already. 5 times 1 minus 1 minus 5 plus 4 over 5. It's just as if you are doing it's just like you're doing a conversion from because this minus 1 plus 4 over 5 is the same thing as writing minus 1. The same thing as writing minus 1 whole number 4 over 5. So that's why we are doing that this thing. I've taught you this stuff many times. I've shown you how to do this stuff many times. You just simply do this. Since there's a plus in between, if there's a minus in between, you can still do the same thing, type of thing. For instance, if there's a minus 1 here, minus 4 over 5, you can just do 5 times minus 1 minus 4. 5 times minus 1, then minus 4. Now give you minus 9 over 5, and that makes much sense, because minus 9 over 5 is simply as saying minus 1 minus 4 over 5. Because minus 9 over 5 is one whole number 4 over 5. So minus 1 whole number 4 or 5, same thing. Alright, so let's, since we have gotten the answer as B, let's Let's solve number 3. F of x is 2x squared minus 1. What is the value of f of 2? F of 2. So 2x squared, what is the value of this? The first thing you do, you put f of 2, you put 2 inside. You may have known how to do this already. 2 times 2 squared, blah 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 blah, and you just keep doing. You do it the first time, put 2 inside, do it whatever you get. Do it the second time, do it the third time, and that's it. Just try it and try to get an answer. Let me check the answer and tell you which of them. Let's try it. So if you don't get 5, you are not correct. Try it by yourself. You can get 5, you're not correct. Alright. Looking at question number 4. If A naught is the initial amount deposited into savings account that earns at a fixed rate of R% per year and a constant amount of 12B is added to the account each year, then amount AN of the savings n years after initial deposit is given by the equation. They have made things easy for you by giving you an equation. What is A3? The amount you have in the savings 3 years after you made the initial deposit. If R equals to 5, A0 equals to 12,000 and B equals to 400. They have made everything so simple for you. So all you need to do, you first put the A1 in there. Put the A1 in there, and that will be equal to 1 plus 3, or 1 plus R over 100. What's R5 over 100? That's like 0.05. You can just do that. 5 over 100 is 0.05. Add that to 1, it's 1.05. You don't like wasting our time, just solve fast. So you have A1 is equal to 1.05, then multiplied by, this is A0. A0 is 12,000. Multiply that by 12,000 plus 12B, and B is 400, so like that's plus 12 times 400. Alright, I know this is a calculator section. This is a seriously calculated section. So solve that. So the first one is 17,400. A1 is 17,400 when you solve this. Now dropping A1, let's go to the next one, putting it as A2 there. Now we're gonna drop A2. Okay, we're gonna put A2 in. Now you're still using that 1.05 for A2. We're putting 1.05. The only thing now that the only difference, you're just multiplying. After you get 17,400, that's 17,400. You just simply multiply it by 1.05. Then add the other 4,800. That 4,800 is just there. It's not moving. It's not moving. So just do the next one. Multiply it. Multiply it by let's do it by 1.05, and then add it to next one you have is 23,070 2307. Now you just put it here, put it in here, 2307, and then multiply again. So solving that, you'll be having 29023.5. That's C, and that's the answer. Let's keep going. Look at question number 5. So question number 5: number of gallons (PN) of a pollutant in a lake at the end of each month is given by the recursively defined formula. See, recursive SAT questions. Okay, so you have Pn equal to 0.85 Pn minus 1 plus 1, 20. You can easily solve this. If the additional amount P0 of pollutant of the lake is 400, so you just simply put 400 here. P1 is equal to this times 400 plus 20. Whatever you get, put it again. P2, plug it in it for P2, because that will be P2 is equal to that plus P1 plus this. Put P1 again now. whatever. After getting P1, plug it in. Then after getting P2, plug it in. After getting P, then get P3, and that will be your answer. That's it. It's quite simple. So let's look at exponential functions. An exponential function is of the form a b raised to power x. Okay, so more like polynomial functions. When you have exponential functions, they kind of grow. Okay, if the negative, if you're having a if they're this way, it means they're kind of decreasing. Okay, they're kind of decreasing over time, while this one they're rising, they're gradually rising and stuff like that. Okay, so we can have decay or growth. Can either decay, dropping, or can grow. So we've saw something like this before, but I'm gonna explain it one more time. When it comes to decay or growth, we have a formula for getting it. We could either use a simple formula of average growth. You can use average growth for if they're asking for average growth. But when we're looking at growth of something, okay, exponential growth, then we'll be using the formula y equal to, so we have y, which is actually f of x, is equal to a into 1 plus r raised to power x, where r is the growth rate, x is the number of time intervals, x like t, okay, time intervals, while a is the initial amount. Is it some persons use y equal to like the y naught, which is the original y, plus some persons use the Euler number or the growth rate r a r y r t, something like that, raised to power t. But any other you use, it still means the same thing. Then if for exponential growth, okay, for when you're talking about exponential growth that involves maybe decay and this thing, and it has to do with the Euler's number there, then you'll be using y, that's the original population of something of that nature, then times the original population, which is y0, raised times the exponent, which is the Euler's number, this Euler's number raised to power the rate of growth times time. Okay, so we're just gonna work with any of these formulas in order to solve any of our questions. Okay, let's look at this question number 1. Although they don't stress you too much when it comes to this, it's just simple questions when it comes to SAT questions. Look at this. During a decade of continuous drought, the water level of a lake has decreased by 10% each year. Which of the following graphs could model the water level of the lake as a function of time? It's decreasing by 10%. The first time it's going to decrease by 10%, there will be a very large decrease. Now you know that when you're talking about increase, you're looking at things like this. These are increments. But when we're talking about decrease, it's either things like this or things like this. Now for the first period, there will be a very large increase. Why? Because 10% is if it was 100, it will go down to 90. 10%, there will be a large decrease. Then if you do 10% of 90, you'll be going to 81. If you do 10% of 81, it's 8.1. You'll be at 7 point something. Okay, and if you do 10% of something, you see that the speed at which it decreases is very small as time goes on. By the time it gets to, let's say, 10 10% of 10, to just be dropping by 10, 9, 8, 10, 9, and smaller. It's even the next one will even be less than 8 and things like that. So it will keep dropping. The speed at which it drops reduced to a point. It gets to a certain point where maybe it's close to 1, and 10% of 1 is 1.1. So if you're having 0.9, 10% of 0.9 is 0.09, and things like that. You're still having very, very low numbers, and it will now start flattening. So this is it. If it's this one, it is decreasing by a certain number. It is the slope here is decreasing by a certain number. Like it is decreasing not just by percentage. It's decreasing by maybe half. It's getting halved. But in this situation, it is decreasing, and it gets to a point where it starts. The curve now becomes smooth. The first time it will drop abruptly, then gradually to smoothen out. Alright, in question number 2, in the above graph, each exponential curve represents the values in dollars of 2 different cars as a function of time in years. At time t equal to 0, the price of model A was 30,000, the price of model B was 24,000. At time t equal to 6, the price of both models were 12,000. Based on the graphs above, which of the following must be through? So they met at t equal to 6. So the first one is at time t equal to 0, the price of model A was 25% more than price of model B. Let us check if that is correct. So we have in 24,000 and 30,000. So the difference between 30,000 and 24,000 is actually 6,000, and you're dividing that by 24,000. That will give you about 1 over 4, 1 in 4, and 1 over 4 is 25%. So I is correct. So the next one we're looking at is at time t equal to 0, the price of model. So at time t equal to 0, the price of model B was 20% less than the price of model A. That is II. Now let's confirm if that statement is correct. So if while t equals 0, they say the price was of model B was 30,000, and the other one of was 24,000, and model A was 30,000. But while t equals to 6, both models were 12,000. So if you're having 12,000 there, so you just simply to see the percentage difference, we subtract 24,000 minus 12,000. That'll give you 12,000. Sorry, time t equal to 0, price of model B was 20% less than the price of model A. All you need to do is 30,000 minus 24,000, that is 6,000, and 6,000 divided by 30,000, that is about 1 over 5. 6,000, 30,000, that's about 1 over 5. 1 in 5. And 1 in 5 is actually 20%. So II is correct. What about the third one? The third one says from t equal to 0 to t equal to 6, the average rate of decrease in the the value of model A was 1.5 times the average rate of decrease in the value of model B. This makes a little sense, but let's check it out first. So the first thing we do is 30,000 minus 12,000. That'll give you about 6. That'll give you 18,000. Okay, so we have 18,000. Now divide that by 6. Divide that by 6. You'll be having 6 and 18. That's 3. You'll be having 3,000. Then that's the average for each year. Is dropping by 3,000. While for model B, we're having 24,000 minus 12,000, which is 12,000. Divided by 6, you're having divided by 6. You're having 2,000. So if you want to know the rate, is 3,000 over 2,000. 3,000 over 2,000 is 1.5. So I is correct. So D is your correct answer. If f of x equals to 12,000 raised to the power 0.9 raised to the power x, and g of equal to 14,000 times 0.85 raised to the power a, what's the value of g of 2 into f of 2? So you simply just insert 2 here and insert 2 here, and that's it, and solve for your answer. It's quite simple. when it comes to exponential growth and decay, we have something like compound interest, which grows exponentially to we have a equal to p into 1 plus r raised to power 2, which is a is the final amount. Remember that is the final amount, that is the final amount that you are going to get when you plug in your money. Now that doesn't show the small amount, the amount that is accrued on top. It only shows the final amount. Then we're looking at exponential growth and doubling. If we are looking at if a population is increasing by a constant rate, we'll be using that same formula. We'll be using the formula for a compound interest. And if the population doubles, if it doubles, we're just using whatever I say is twice what's here. And if it's moving every d years, that t over d there represents the number of time periods. So that t number of time periods here is same thing as this t over d, number of time periods. So that's quite important to know. Then if you're looking at the exponential decay and half-life, we use decrement. We use decrement instead of that's a subtraction instead of an addition. Since it's decreasing, we're using decrement here. Then if it is if it's something that's increasing, maybe growth of a particular thing, we use plus. But when we are having a decay, we're using minus. Then if it's half-life, we just look at when is it going to reach that half, the time that it will take to reach that half half-life, half of it. Okay, like something is decaying, when will it reach half of the amount of it? Another thing, when you're doing that, you just simply do p into 1/2. Okay, because that's half of the population of anything you're having, a half-life of the size of anything, and you are raising it to the time periods. Okay, all right, let's go forward and solve some of the questions. So let's solve question number 1. The number of rabbits in a certain population doubles every 40 days. If the population starts with 12 rabbits, which of the following gives the total population, the total number of rabbits in the population after t days? So it will double every 40 days. Okay, so you're having 12 rabbits, that's the start. Remember, you're having 12 rabbits at the start, and it is doubling. That's times 2, but it is doubling every 40 days. Remember we're having 40 over the time frame. So in t days is either 40 t or 40. Okay, because if it hasn't reached the point yet, it's not even gonna double. But when it's 40, if it's 40 to be 40 over 40, that's 1. So it would have doubled by the time it's 1. But if it's let's say 80, then it will be 2. So it will double, and it will double twice. Like, that's what it means. So if it's 120, so it's t over 40. That is d. Okay, so let's go to the next one. So here in number 2, population P of town is 80,000 this year. If population in the town decreases at a rate of 4% each year, which of the following expressions gives population P after t years? So this is it. 80. You have to write 80,000. Okay, I'm not saying that's the answer. Please, we are having 80,000. Okay, 80,000 is the current population. So we said if it is decreasing, we'll definitely be using 1 minus r raised to power the time frame at which it's working. So the 4% is given by 4%. That's 0.04 percentage. That's the rate. There. So it's 1 minus 0.04, and that's 0.96. Yep, 0.96, and it's doing it every year. It's decreasing by that each year. So it's raised to power t. Okay, raised to power t. So this is the answer B here. Okay, this was it. 8,000 into 1 minus r t. If it is decreasing, it's negative. Alright, so let's move to the next one. if you're having question number 3 there, a house bought 10 years ago for 150,000 was sold for 240,000 this year. Which of the following equations can be used to solve the annual growth rate of the value of the house? So if it sold for 240,000 this year, it was bought for 150,000 and sold for 240,000. So there's a growth, and how can we get that growth? We use the same formula and get it. So 10 years ago, that was 10, and now remember, it is the 240,000 equal to the 150,000 times into 1 plus r, what we mentioned, since it's growing, is plus the percentage growth rate, and then raised to power the number of years. Since the number of years is t, that's 10, you can easily get the rate, the growth rate then. Alright, so that's C is the answer there. Okay, they're just asking you based on what I've showed you what the answer from the other the explanation I gave. So look at a certain radioactive substance has a half-life of 12 days. You know what to do with half-life is 1/2. Okay, this means that every 12 days half of the original amount of the substance decays. If there are 128 milligrams of the radioactive substance today, so there are 128 milligrams of the substance, that's 1 times 1/2. Remember, if you are doing you are doing P, that's the number of amount that is going to be there left, will be P original into 1/2 raised to power the rate of the day. Like if you're having t days, okay, so it will be divided by the number of time periods. Let's say the time periods is d. Okay, alright, so let's do that. So now if the time periods that you're talking about is 12, they are giving you 48 days in order to drop 128 milligrams of a radioactive substance. So 48 divided by 12, that's definitely saying 48 divided by 12 is 4. Okay, and that's 1/2 raised to power 4. 1/2 raised to power 4, this is 2 raised to power 4, which is 16. So you're having 120 divided by 16. 120 divided by 16, let's check that up. So 128 divided this 8, not 20. 128 divided by 16, and that will give you 8. So your answer is 8 here. All right, let's go to the next one. I hope you understand what we're doing here. I hope you really understand it. All right, questions number 4 and 5 I would like you to do by yourself, but the very next is your test. So you still have options of where to go. So let's look at this. Evelyn deposited 3,000 into her bank account, which earns 4% interest compounded annually. She uses the expression 3,000 raised to power x to find the value of the account after t years. So if you're having 4% there, that x there represents since it is growing, is 1 plus 0.04 raised to power t. So your x there represents 1 plus 0.04, which is 1.04. Okay, that's quite simple and very fast, straightforward. From what we have been doing, you know, you have to do p into 1 plus r raised to power t. This is your compound interest. This is your interest formula. All right, let's go to the next one. Remember your percentage there is in decimal. All right, let's look at number 6. Evelyn deposited the same amount into an account that earns 5% interest compounded annually. How much more money than her original deposit in the account with 4% interest rate compounded annually will she have earned in 10 years? Round the answer to the nearest dollar. So if Evelyn deposited this in an account of 5%, so what we'll be having will be 1.05. Okay, so how much more money than her original deposit in the account with 4% interest rate compounded annually will she have earned in 10 years? So we're just going to solve for each. We're going to do 3,000 into 1.05. That's 3,000 times 1.05. But 1.045 raised to power 10. That's what we're doing. The first one will be 1.05 raised to power 10. raised to the power 10 minus 1.04 raised to the power 10. Then whatever we get, we multiply by 3000. This is like factorizing this stuff, because you see do 3000 times this minus 3000 times this, so just factorize it and get 3000 in the middle. Okay, put 3000 here. So let's go. 1.05 raised to power 10, it will give you 1.6288. 1.6288. Okay, 1.6288. You can use your calculator and do it even faster. Then you have 1.04. I know you can do this real quick in your calculator. Raised to power 10 will give you 1.48024. I'm going to plug in the next value, 1.62889 minus the answer 1.62889 minus the answer. We get 0.148, and I multiply by 3000, and I'll be getting $445.93. $445.93. So if you round that up, it'll be $446 in the nearest dollar. So that's it for number 6. Now you have your test coming up. Your test is coming up, and alright, so this is your test. You could, instead of us screenshotting it, you could just pause your video. I'm gonna zoom into each of them. So you could pause your video and check out each of the tests. This is question number 1. This is question number 2. This is question number 3. Question number 4. Let's zoom this out. Question number 4. See, question number 4. The half-life of a radioactive substance is the amount of time it takes for half of the substance to decay. The table below shows the time in years and the amount of substance left for a certain radioactive substance. Okay, how much of the original amount of a substance? This is just looking at the. You just need to look at the board. Try your best in that question. Try to use what we have learned. Look at question number 5. Okay, let me stop on that. This is question number 5. Right. This is question number 6. Question number 6. Also quite a simple question. Question number 6. Then you have question number 7, which you will input your answer. Please input your answer and state it out clearly. This is question number 8. This is what you need for question number 8. Okay, you need this for question number 8, and this question number 8. So let's keep it together. Question number 8. This is question number 8, and this is question number 9. Alright, so that's it. Do your test and let's see your score.